Hey everyone, I'm Alex. Welcome back to Awful Astronomy. Now, you may have heard about the giant impact hypothesis, in which a hypothetical, roughly Mars-sized planet named Theia collided with the Earth approximately 4.5 billion years ago. The debris that was ejected during this collision would then have formed a ring around the Earth, similar to the rings of Saturn, which eventually coalesced, forming the Moon. You've heard of the Moon, right? Well, wake up, babe, because a new giant impact hypothesis just dropped. But this time, it's about our sister planet, Venus. Being the second planet from the Sun, Venus is often referred to as Earth's twin or sister planet, because some of its properties are similar to our homeworld, like its mass, radius, density, and even the semi-major axis. So that must mean it's a really pleasant place, right? Right? Heh. Quick, do you know what the hottest planet in the solar system is? You would think it would be the one closest to the Sun, so Mercury, but not so fast. Mercury's maximum surface temperature might reach up to 430 degrees Celsius on the sun-facing side, but Venus tops it with 465 degrees Celsius. How is this possible? The answer is something that we contend with here on Earth as well, the greenhouse effect. In case you need a refresher, the greenhouse effect is the process whereby certain gases in a planet's atmosphere trap heat. Venus is a prime example of the greenhouse effect on steroids, because its atmosphere is 92 times denser than Earth's, and over 96% of it is carbon dioxide. In planetary science, this sort of extreme case is called a runaway greenhouse effect. We should also talk about the clouds that cover Venus everywhere. You want to know what they're made of? Sulfuric acid. Yeah, the surface of Venus is not a pleasant place to be. Now, I don't want to withhold anything from you. We actually have pictures from the surface of Venus. Here they are. Looks like a nice picnic spot. Both the United States and the Soviet Union attempted several times to land, but because of the extremely harsh conditions, almost all landers were destroyed before they hit the surface. Several Soviet Venera probes made it, however. The pictures you're looking at were taken by Venera 9, 13, and 14. The Venera program was actually a massive success. Venera 7 successfully crash-landed on the surface of Venus, thus becoming the first man-made probe to land on another planet and transmit data back to Earth. It survived for 23 minutes. Venera 9 was the first probe to transmit pictures from the surface of another planet. The whole program actually really deserves its own video or series of videos, but we'll move on for now. There is something strange about Venus that I haven't mentioned yet. Its orbit. First off, a day on Venus lasts around 243 Earth days. That's longer than a year on Venus, which is about 225 Earth days. That's right, on Venus you will go once around the Sun before going from one sunrise to the next. We also need to talk about axial tilt. Maybe you remember from school that Earth's axis is not perpendicular to the orbital plane. Its tilt of about 23.5 degrees is actually what causes seasons, not distance from the Sun. If it were a matter of distance, then why is December a summer month on the southern hemisphere? Not to be outdone, Venus is once again taking things way too far. Its axial tilt is 177.36 degrees. That's almost a full north-south flip. In this animation, you can see the axial tilts of all planets in the solar system, plus Pluto and Ceres, which really puts things into perspective. Sure, Uranus and Pluto are wacky too, but Venus is on another level. So why is it like this? What caused such an extreme tilt in Venus? Well, that's what this recent paper by a group of Swiss astronomers tackles, so let's get into it. Now, as the paper is quick to point out in the introduction, there is, as of yet, no hard evidence to prove an impact of the magnitude we're talking about here. But on the other hand, the giant impact hypothesis that I mentioned earlier, the one that states Earth got its moon through the impact of a Mars-sized object, is widely accepted these days, even though we of course have no crater to show for it, because too much time has passed since then. Remember, this event would have happened around 4.5 billion years ago. The meteorite that wiped out the dinosaurs only happened around 65 million years ago. So, if an impact like this did occur on Venus, we might not be able to tell simply by looking at the planet's surface. If we don't find a smoking gun, we need to rely on circumstantial evidence, like Venus's axial tilt and extremely long days. Both of these could have been caused by a giant impact. Quick aside, it really isn't that strange for Venus to also have had a giant impact. In fact, it seems statistically probable that it would have had one. We already talked about Earth, but there's also the theory that Mercury's unusually high iron-to-rock ratio was caused by a giant impact. And then there is Mars's crust-tilt dichotomy, which refers to the fact that the two hemispheres of Mars's surface are polar opposites. Haha. Seriously though. The northern hemisphere of Mars is a mostly flat and low-lying landscape, whereas the southern hemisphere has mountains, valleys, craters all over the place. Theories about why the Martian surface is like that include one or more impacts. So why shouldn't Venus have one too? As the authors point out, a giant impact is a viable explanation for Venus's strange rotation, but it depends on what its rotation was like before the impact. In order to understand that, we would need to learn more about Venus's accretion history. There's also the matter of the Moon. Again, impact events such as this result in a debris disk around the larger body. In Earth's case, this led to the formation of the Moon, but that doesn't necessarily have to be the case. The stated goal of this paper sums up its tasks quite nicely. Quote, "In this work, we investigate whether, and under what conditions, a giant impact is consistent with Venus's rotation rate and lack of a moon." End quote. To do this, the authors used 3D impact simulations with varying parameters and checked which initial set of variables resulted in the Venus we see today. So, how did they do? Well, after a total of 81 simulations, 64 ended up being complete mergers of the two objects, 7 raise and merge, and 10 hit and runs. In this picture, you can see the simulation of a head-on collision, the result of which is a merger. This run used a non-rotating Venus and an impactor with 0.1 times the mass of the Earth, traveling at a speed of 10 km per second. Here you can see an oblique collision, which just means that it's not a head-on collision. This one uses the same parameters for the impactor, but with a rotating Venus this time. This one ends up not as a merger, but as a hit and run where the second body escapes. When we compare the end results though, they are almost the same, except that the merger produces a lot more heat. And that is essentially what this paper finds, that various unknown factors concerning pre-impact Venus combine with various types of impacts to produce the Venus we see today. So yes, a giant impact could have made Venus what it is, but we don't know which type of impact it was because we don't know enough about Venus before that impact. One thing I will say is that mergers are theorized to activate plate tectonics in a planet at least for a little while. Venus does not have global plate tectonics like Earth, but it does have volcanic activity in spots. What all of this means is that we need to do a lot more science before we can really understand the evolution of Venus. And we're in luck because there are several Venus missions in the works, like ESA's Envision and NASA's Da Vinci and Veritas. Okay, that should do it for this time here on Awful Astronomy. If you stuck around this long, I want to say a huge thanks and I hope you learned something today. Please, while you're here, give me a like, leave a comment and subscribe if you want to see more videos like this one. Also, if you have any suggestions for what to cover next, please leave them down in the comments. I'll be sure to add it to my list of topics. Alright friends, remember that you're all beautiful, lovely and deserve to be happy. Until next time, stay stellar!